Hi everyone, welcome.
Hello, everyone.
We're up to around 30 people now. Lovely. So if you're wondering, um, David is looking a little weird today. That's because we have Julia joining in as a last minute substitute for David.
Hello,
Um,
everyone. Pleasure to be here. Everyone is so on time. That's a lot of very punctual people. Amazing.
we are going to wait for 1 or 2 minutes until the less punctual people join, and then we'll start. Yeah, we had a discussion, and it turns out David's participation would probably require him taking a call from Heathrow, which we thought was a little risky. So that's why we have Julia.
Yeah, you will get more of the engineering talk instead of the CEO talk. Whether that's good or bad, decide for yourself. We even have Korea. What hour is it there now? Isn't it like the middle of the night or something?
All right, so looks like there's already quite a lot of people. It's time to get started. So welcome everyone to our Assessing Gen AI Security Solutions in the Wild with the Pint Prompt Injection Test Benchmark webinar. So as I mentioned, we have two panelists today. So myself, I am a ML scientist at Lakera, and Julia, who is a surprise guest because David could not make it because he is currently at an airport. Julia is an ML engineer, and we work together closely. We also both worked on this Pint benchmark, so we're very excited to, yeah, to let you guys know what it's about. So just a quick intro about Lakera. We're a company that secures GenAI applications for some of the world's most exciting leading enterprises. We make Lakera Guard, that's our main product, Lakera Red. A lot of you are probably here because of this little guy on the right, Gandalf. So we made this game that has since turned into a like the biggest AI security resource. So it's part entertainment, part education. If you haven't yet, you should definitely give Gandalf a try. And yeah, so today is going to be about prompt injection. So we should first make sure we're on the same page about that, Julia.
Yes, sure. So in general, a prompt injection is something that happens when an LLM app mistakenly prioritizes malicious instructions, and this makes an LLM execute something that conflicts with the creator's instructions. And you can see some examples here. And this is a real risk for many people building LLM-based apps. And I would imagine many of you actually are doing exactly this. So if you are here, you are probably already convinced that you should take care of it. And yeah, next slide, please. But first, I want to say a few words about why we made this benchmark at all, because this is something that we've seen when we were interacting with clients, that there is actually a need for something like this. So let's imagine for a moment that I'm not a machine learning engineer at Lakera, but I'm actually an AI security engineer at some other company. And I want to secure my company's LLM app. So once I'm convinced that I actually have to do this, my main question will be, how do I do this? And this means that I will have to choose the best AI security vendor. And not only I'll have to choose the vendor, but I will probably also have to convince the upper management that this is the correct choice. And what we've seen in general, our clients always do is that they find some data that's relevant to their use case and they evaluate different solutions on this data. But this is kind of tricky. If I'm building a very specific application, then maybe the data that I find online will not reflect how people will use my application, right? So that's one issue, that the public data on prompt injections is very scarce and it very often has a bit of a limited domain. So if you have data that comes from games like Hack a Prompt or Gandalf, it's very specific to the particular game, right? So it's probably not very specific to your particular use case. And you want to be able to say to other people that if we choose this vendor, we will catch this percentage of prompt injections that people will try to execute in our LLM app. So that's one issue. We want to have relevant data for your use cases. But on the other hand, these existing public data sets are subject to Goodhart's law, which says that when a measure becomes a target, it ceases to be a good measure, because this is a term that if you're any into machine learning, you've probably heard the term overfitting, which basically means that the solution, instead of just being general and solving all the use cases that you want, it actually just solves the particular use cases that are in your data. So maybe the prompt injection detector performs very, very well on these public data sets, but it doesn't necessarily perform very well on your use case. And this kind of showed us an opportunity for us to share our expertise that we gained when we were developing Lakera Guard. We actually, over the last months, we have discovered multiple holes in our own solution, and we patched them up. And we also want to make sure that people can also see this, and they're aware of the fact that there are just so many different ways that a prompt injection detector can fail. And over to you, Václav.
Sure. So now that we have the motivation, let's talk a bit more specifically about what Pint is. So it consists of, the benchmark consists of two components. There is the GitHub repo, which is publicly available, and it contains the code that you actually need to run this benchmark. And then there is the data. So the data is not available on a public GitHub repo, but you can ask us to get the data set and we will give the data to you. The reason it's done this way is exactly because of Goodhart's law that Julia mentioned. Like, we don't want people overfitting on this data set, because then it's no longer a good measure of whether a classifier is a good prompt injection classifier. We also have a mechanism to update this data set if needed. So then if this actually does happen, we will update it and hopefully be able to reduce this effect. There's also a written introduction that you can read on our blog that you can see the link to there. And we've also run this benchmark on a bunch of models, obviously Lakera Guard, our product, but also some of the publicly available prompt injection detection models. You can see the results of that here. This is a screenshot from the README, as you can tell. Now the Pint benchmark scores, we have Lakera Guard coming out on top, and then a bunch of other data sets. Some of these are APIs, and some of these are directly Hugging Face models that you can run locally. Now, you're probably not surprised that we land on top of our own benchmark, and we don't want to, we want to be transparent about this. Like, of course, because this is based on our expertise, because this is based on our data, we will have a high score on this benchmark. To be clear, we don't train on this exact data, but some of it are data sets where we have a train and test split, and then we train on the train split, and the Pint benchmark contains some data from the test split. But it's still unavoidable that there is some information leakage between these. And we're not trying to convince you with this number, but what we're trying to convince you with is try to take this data set as well, and feel free to modify it, create examples, other examples based on the data, add typos, different augmentations to test for how robust these products are and get a feeling for it. So you can think of the data set as being a starting point for you making an even more fair evaluation. I mean, this is a bias that is obviously very difficult to remove, but we try to do what we can, given that it's still the same company, So we can, I mentioned the Pint score, but I didn't really explain how this is actually computed. And there are two things that go into this. In simple terms, it's balanced accuracy, which means we take the average of the accuracy only on negative data and only on the positive data. The reason we do this is there's two sides to a prompt injection detector, or any binary classifier really. You want the model to detect prompt injections reliably, but also if it over triggers, if it flags too many things as prompt injections, even benign ones, then it would become it would make the application unusable, right? So you can't also just rely on accuracy alone in the naive sense, where you take all the data and you compute how many of these are correct, because there is naturally a lot more negative, so a lot more innocent data than prompt injections. So we solve this by using balanced accuracy, which gives much more weight to the rarer classes, because it's just a 50-50 average. So you can also see on the right that we have several categories that go into this dataset. I can talk about that later, but as a high-level overview, the negative datasets include chat interactions, so things that people might you paste into chatbots like ChatGPT or any customer applications, then documents, so whatever longer form text, and then hard negatives, which is internal data that we crafted so that it's innocent, but it contains certain words like ignore that are often correlated with prompt injection. Then we have positive data, and that's a mix of our internal data sets, so largely based on Gandalf, from which we have the world's biggest database of prompt injections, then some other public prompt injection data sets, and jailbreaks such as Dan and others, if you've heard of those. So that's the mix of data that goes into Pint.
And very quickly, how do we actually use Pint? Well, if I come back to my persona of an AI security engineer, it's pretty straightforward for me. I just clone the repository, I request the access to the dataset, or alternatively, I use my company's resources to create a dataset, and I just run a simple Jupyter notebook that will spit out a number. And this way I can actually get hard numbers, which I can then use to argue with people about which vendor solutions I should use.
Right.
And now the last little surprise at the end. We will be attending the RSA conference next week. So if you're around San Francisco, please use the QR code here to book a one-on-one meeting with us. And the what I am personally really excited about is the new Gandalf level. So it will be actually a self-learning level. So it's really, really the hardest one that I have played. I saw that some people in the chat were writing that that they managed to get through level 8. This will be a challenge for you as well. So yeah, don't hesitate to book a one-on-one, and maybe we can have some questions now. Okay, let me see. Do we have questions? Okay, we got one question about what are hard negatives. Václav, do you want to answer this?
Yeah, so as I mentioned, hard negatives are certain samples that are difficult for prompt injection detectors due to their nature. So I mentioned the word ignore. Often sort of the textbook prompt injection is something like ignore all previous instructions and do X. So then you might have a natural document that contains the word ignore in a completely different context. But if your prompt injection detector is not robust enough and only learn to recognize prompt injections by presence of the word ignore, then it will fail on these kinds of samples. So the way we produce these is look for these sorts of keywords in natural data sets of text. We have words like ignore, instruction, and prompt, and yeah, we have password as well, which is specific to Gandalf, right? So want to avoid that one. In general, it's a test for shortcut learning, which is a topic you can also read about on our blog, and something that every kind of model struggles with.
I hope that answers that person's question. I see we have another question here, and that's that Pint is only English-based. What about other languages? Yes, that's a great question. Let me answer this. So it is indeed English only at the moment. We do have plans in the future to expand it to other languages. But we actually are working on multi-language support in Guard. We have released a model now which has increased coverage on Spanish, German, French, and Italian. So I also invite you to try it out. And yeah, the next version of Pint is coming. Definitely.
I'm looking at other questions now here. There's one. Can you please share industrial cases of clients using your offerings? So maybe I can comment on that. I mean, I can't really disclose the specific use cases, but one type of use case that does come up a lot is customer support chatbots. So that's something that's a big use case that people are doing now. So you're a company that sells whatever, some kind of product, and then you want to automate customer support via LLMs. So either you just give information from a knowledge base, or you also have your model be able to take some actions on behalf of users, which makes the use case more high risk. But because this is relatively easy to implement and not that high risk, it's something that we see a lot of companies going for.
Okay. I hope that answers the question. And now another question is from Diego, who says that he's surprised that scores on Pint are so high. Is jailbreak detection solved and no more work is warranted? If not, how to make a benchmark that reflects this? That's a great question, actually. I think probably the main reason why, yeah, we can get back to the scores. So you can see that from the overall scores of different solutions, well, it's certainly not a solved problem. And you can, I guess the question is, what do we actually consider solved, right? Especially the space of prompt injections is evolving as we speak. So almost every week there's basically a new method of prompt injecting a model. And well, we'll keep updating the Pint benchmark to reflect this, because that's well, this is just a snapshot in time. There are many different ways of attacking models that are not obvious now and will get discovered in the future. So this is definitely not a solved issue. We are pretty good at it, I guess, but I would not consider it solved at all.
For sure. Okay, let's see here. We have a question from Philip asking, how good are LLMs at breaking the shields? So I guess that question is about sort of LLM assisted red teaming, where you have not a human trying to get through these systems, but an LLM that might interact with the system and another LLM. Like we've seen people who solved Gandalf using another LLM, which is quite an exciting project. But and there are also some academic papers on this sort of thing. But there's always the question of like, how much effort did you need to do the prompt engineering to get this right? So even though it eventually works, it's not clear if it works because LLMs are just so good at this, or because you put a huge amount of effort into crafting the perfect prompt that's going to make the LLM do what you want. And at that point, you're more doing the programming yourself than the LLM exhibiting any sort of intelligence. So my answer would be not really good enough to be practical attacks. But let's wait for like GPT-5 and see.
There is also a question about the data on the prolonged conversation injections when there's a lot of back and forth between a user and an AI. As far as I know, this is not included in our benchmark at the moment. We do not support multi-message attacks yet. That is in the works, but yeah, we can't do everything at once.
Maybe to add to that, most of these prompt injection detectors, ours included, work on this single prompt level. So even if we had this multi-turn data there, it's not clear how to run these, but it's definitely one of the frontiers of prompt injection research, how to extend this to longer conversations. So there's a few questions about how this is computed. So there's a question, do you have a specific formula for calculating the percent benchmark? If I understand the question correctly, you are referring to the balanced accuracy here. So again, we take all the negative data, compute the accuracy on that. Then we take all the positive data, compute the accuracy on that, and then we just take the arithmetic mean of these. You can also look up the code on the GitHub repo that's linked here and check the formula yourself. What I also didn't mention, by the way, is that with this repo that we have, you can also run evaluations on any data set that you want if you convert it to the correct format. So it could also be useful for evaluating, since we already have these implementations for evaluating, for example, the Hugging Face prompt injection models. You can use this code to run these on any data that you want.
And maybe I will also jump in and add here that the fact that the Pint score is basically an average of accuracy on positive and negative data, then it means that if you had a detector that says that everything is a prompt injection, then it would get 100% accuracy on positive data, but 0% accuracy on the negative data, which would yield a score of 50% in the end. Correct me if I'm wrong, Václav.
Yeah, that's correct.
Maths here. Amazing.
Yeah.
Yeah, let's look at some more questions. Is there a way for you to detect whether or not a model trained with your benchmark data set? That's an amazing question. I think this is in general a question that relates not only to us, but also to, well, basically the whole machine learning community, right? We have this very well-known court case where the New York Times sued OpenAI for training on their copyrighted data, and well, it's not it's just not possible to say whether a model has been trained with particular data. However, well, with Pint, I would find it suspicious if tomorrow someone came up with a model that scores 100% on the data.
There is, if you're interested in this, the keyword to search for is membership inference, where there is research on exactly this sort of thing. Like, can you figure out if a data point was used in a training set? There's a question from Shen, I'm sorry, that I like here, referring to the table where you compared Pint scores. Given that Lakera is based on prompt injection data from Gandalf, and Pint is also based on prompt injection data from Gandalf, does that mean that Lakera will naturally have higher score versus other products? Yes and no. We will naturally have a higher score for the reasons I mentioned, which is simply we are the ones that created this data set. So we are sort of closer to this data, although we make sure not to train on this specific data, but it's natural that this will give us an advantage. And again, I encourage anyone to play with this data and create variations that will get further away from this distribution. But to the Gandalf point, it contains, it is the case that it contains Gandalf data, but I want to clarify we're not just pulling random data points from Gandalf. Like, these are very specifically curated because a lot of the Gandalf data is specific to the game and is related to extracting a password, which is not really what you want to do in a real life use case. So we look for specifically what we call, what do we call this? Like general prompt injections or context-free prompt injections, where these are prompts that will be relevant no matter what your use case is. So things like ignore all previous instructions and do something, and or prompts that try to leak what the system prompt is, or whatever says something like stop, now do something else. But if it's password related, then we wouldn't include it, and we wouldn't even consider that to be a prompt injection in this context-free sense. Like outside of the Gandalf context, it's not really a prompt injection. So we make sure to get this sort of data.
Let me double check whether we haven't missed any questions here. I see there was a question from Doug that we have not answered, whether we have considered making this an OWASP project. So no, we have not so far considered making this an OWASP project, but we have collaborated with OWASP recently on the OWASP LLM security verification standard. If you're curious, we did a webinar about it a few weeks ago. I invite you to check it out.
And there's another question from Doug. Have you looked at having an LLM use the true positive data and false positive data to come up with new attempts / data? I can't go into details here, but essentially, yes, we are using LLMs to enrich our data and create more of it. And now this is sort of part of the secret sauce, so I can't disclose too much. But yeah, we are definitely looking at using LLMs for that. One interesting challenge there is if you're using an LLM to process prompt injections, because of the fact that they're prompt injections, sometimes your LLM that's supposed to whatever, like rephrase or augment the data will also fall victim to this prompt injection. So that's an interesting challenge that you wouldn't have with other kinds of data.
Maybe I'll also jump in here. Recently, there's been a lot of interest in that question on the side of research, and there's quite a few papers that explore this. But one of the issues that are one of the issues that come up is that it's really hard to judge whether a prompt injection is successful actually, because yeah, it's sometimes they're like kind of successful, sometimes they're not. So basically such projects very often involve very complicated pipelines involving multiple LLMs, where it's always an LLM judging if something is a prompt injection. So it's a bit, this research area has a bit of an issue with well, bootstrapping, let's say, that well, basically we're using LLMs to check if this prompt injection could break an LLM. Yeah, this is I think this is something that the field is struggling with.
Definitely.
There's also a question about whether the new Gandalf level will be learning on all users or just on one user during their attempts. Are we allowed to say how the Gandalf level works?
I think so, at least on this level. Yeah, it's learning on all users. So yeah, if someone, at least as far as I'm aware. So yeah, if someone submits a solution, then it's blocked for other users. And I hope I'm not saying this wrong because I did not work on this level. I was testing it today though.
It was really hard. It was so hard.
Yeah. I think perhaps we have time for one more questions and then we're going to have to wrap up. Or what? Or let's do two. Any interesting new attack methods? I like that one because yeah, Julia and I are working a lot on keeping up with the latest research. I know, Julia, anything that comes to mind first?
I have a relatively fresh one and a bit of a throwback. So a fresh one is the rainbow teaming paper, if you're maybe familiar with it. Basically, it's one of these papers where they use a complex pipeline and an optimization methods in order to generate more jailbreaks. So that I found particularly interesting because it seems like it's a pretty successful method to generate jailbreaks and prompt injections, or at least so the numbers in the paper claim. So that's my let's say a fresh paper. And a bit of a throwback is that maybe some people here are familiar with the universal and transferable adversarial suffixes, or yes, I'm sorry if I maybe confused the title of the paper a bit, but it's basically a way to use coordinate gradient descent to generate new suffixes, which basically make a prompt, let's say a malicious query, always successful, just in a nutshell. And why I'm bringing this up is that I actually recently I was checking whether this still works on ChatGPT, and even the exact examples shown in the paper still work on ChatGPT, which I found pretty successful, or at least worked when I was checking. So
yeah.
What's your recent highlight, Václav?
I want to mention, and I think we'll stop there because this was a bigger question. It's the paper from Florian Tramer's lab about the poem repetition. I don't know if you can look that up, Julia. I don't remember the title of the paper and I'm sharing the screen, but the paper essentially shows that when you ask and this is an effect that multiple people have noticed, but when you ask ChatGPT to repeat the word poem infinitely, it doesn't have to be poem, actually, it's just about repeating a single token over and over. Eventually, it stops doing that and starts producing some gibberish that seems to repeat the training data. So then they check whether what it produces is actually the training data, because that's relevant for these copyright purposes. But it's really weird that it even like at some point stops repeating poem and starts doing something completely different. And it seems to be an artifact of just GPT 3.5 and probably something to do with how the context window is handled. So that's really interesting to see how these models might be diverging, and it might not be enough in the future to just say this is a prompt injection or not, but we might have to start saying this is a prompt injection for this version of this model under these circumstances. So that's definitely an exciting research direction. And with that, thank you for joining. I will leave you with a few resources here. So we are trying to be a leading AI security resource, so that's why we have this webinar. But we also have a bunch of other cool stuff. So we have these guides that you can download, and we have a blog where we tackle different AI security and safety topics, a bunch of stuff around prompt injection, but also other stuff. So check that out. And with that, thank you for joining. If you're interested, if it's relevant for you, of course, please try Lakera Guard. It's free to access, and it performs the best on the Pint benchmark. So obviously you should try it. And yes, reach out to us if you're interested in having a look at the Pint dataset. We'd be happy to provide. And yeah, thank you all for joining.